Welcome to 9.1 Angles of Elevation. So last time we got together, we were talking about trigonometric functions. We looked at Pythagorean theorem, we looked at sine function, cosine function, and tangent function. So we're going to just kind of put some of our functions here on the side just so that we've got them as a reminder. So we're going to use sine, which is opposite over adjacent. Opposite over hypotenuse. We also kind of refer to that as so. We have cosine, and that is adjacent over hypotenuse. We think of that as ca. And then we have tangent, which is opposite over adjacent. And we think of that as TOA. So these are kind of like our little shortcuts to remember our trigonometric functions. So when we're talking about angle of elevation, we're talking about the angle in relation to the ground itself. So we're going to take a look at our top these that says at the top of our page. And I'm just going to blow this up just so we can see it just a little better. So it says, which is the measure of the angle of elevation? So we want to be able to identify, is it going to be this one, which we know is 90 degrees? Is it going to be this one, 65 degrees? Or is it going to be this one, 25 degrees? So just a reminder, the angle of elevation is in relation to the ground. So if I'm looking at this triangle, I would assume that this information here, that this is going to be the ground. Or ground level. So we're looking at the angle that is in relation to that ground level. So if this is the ground, so here's the angle that's in relation to that ground level. So this is the particular angle that is considered angle of elevation. So basically, if we look at the ground and we look up, we're looking at the angle that's kind of looking straight up. So we pretend if we're the one standing here at the ground and we're looking up, this is the angle that we're looking at. So we're going to label that as angle of elevation. And we know that it is 25 degrees. Okay, so let's take a look at this one. It says write an expression to use for calculating the angle of elevation. So here we have our triangle. We know that this is the right angle. And we know that this has got to be the ground right here. So if that's the ground, which of these angles is the angle of elevation? So it has to be in relation to the ground. So it's got to be this one. So this is the one that we don't know anything about. So we're missing that angle of elevation. So we're going to write a mathematical expression in order to help us solve for that if we were to do that. So here is our angle of elevation. We've got some pieces of information that we can use here. So we've got this side, and if we notice that it's straight across from the right angle, so we know that this is a hypotenuse. And then we've got this side, which is right beside the angle of elevation. So we know that this is an adjacent. And because we know adjacent and hypotenuse, we know that we're going to be using cos. So we would find the cos of x equals our adjacent over hypotenuse. And then we know it'd be 29 over 33. We would solve for whatever this happens to be. So we would take 29 divided by 33 on our calculator. We would get, so cos of x equals 0.8788. We're going to round it up to the 4th decimal place. But we need to find out what the angle is going to be. So we do our inverse. So cos inverse of x equals, cos inverse of 0.8788 equals, you'd punch that into your calculator. Remember that this is saying second function cosine, and then type in the decimal, second function cosine, 0.8788, close your bracket, equals, and we get 28.5. We're going to round it up to like 29 degrees. So this angle here of elevation is 29 degrees. All right. So we're going to take a look at the example that they give here. So Area, she builds roof trusses for a construction company in Medicine Hat. He needs to cut the ridge beam at an angle to attach it to the rafter. So the cut angle must match the angle of the elevation of the rafter, or x. At what angle should our Area cut the ridge beam? So if we take a look here, we've got our piece of information about the rafters. So here's our triangle that we're working with. So what I'm going to do is just kind of redraw it so I can see it a little better. So we have a right angle here. This is 6 feet. This here is 12 feet. And this is the x that we're looking for, because this is the angle of elevation. So it asks here, what equation can you use to calculate x? So we can take a look to see what we have here. I'm just going to make it a little bit bigger so we can determine what it is again. So here we have our information. We've got 90-degree angle, and straight across is the hypotenuse, but there's no information here, so that means that we're not using it. So here's the angle of elevation that we're looking for, and we look straight across that to the other side of the wall, and we've got 6 feet, and we know because it's straight across and opposite, this is our opposite side. And then we've got this side, which is right beside the angle of elevation. This is the adjacent side. So we're going to take opposite and adjacent, and from our trigonometric ratios that we wrote down on the left-hand side, opposite over adjacent means that we're going to be using tan, or tangent. So we're going to set it up here. So what equation would we use? We're going to use tangent. So tangent of x equals the opposite over the adjacent. So the opposite is 6 and the tangent is 12. So now we want to find the inverse. Find inverse to find the degree of the angle. So we want to find the degree of this angle. So in order to do that, we're going to take tan, second function tan, and you can do this right onto your calculator. Some of you might be more comfortable with figuring out what the decimal is first and then using it in this place, but you can do this on your calculator. So you would hit second function tan, second function 10, and it'll open up a bracket for you. And then you can do 6 divided by 12, and then close your bracket and then hit equals. And it will give you your answer. So it says to us that x equals approximately 26.57 degrees. So what is the cut angle to the nearest degree? So 26.57, we're going to say it's about 27 degrees. So area should cut and add an angle of about 27 degrees. Okay, we're going to look at our next one. Shayna is a machinist. She uses a sine bar and gauge block to measure angles very accurately. For this project, the angle of elevation must be exactly 34.5 degrees. So which gauge block height should she use? And you're going to express your answer to 4 decimal places. So if you take a look at the information, here's the angle of elevation. It's 34.5 degrees. Here's the gauge block. That means we need to find out what it is here. So we're going to label that. I'm going to use red. We're going to try and find out what this side is, what the length is. And this is our hypotenuse, because remember it's straight across from the right angle. Here's the hypotenuse, and it's 5.0000 inches. So we're going to label that as hypotenuse. And this side that we labeled as x, it's straight across from the gauge block, so we're going to label that as opposite. And this side we don't need to use. So we've got hypotenuse and opposite. So which trigonometric ratio are we going to use that has opposite and hypotenuse? You should be able to tell me. And we're just going to do our work here on the side. All right, so we're going to be using sine. So we're going to use sine of 34.5 degrees equals our opposite, which is on top, over our hypotenuse, which is on the bottom, and we're just going to say it's 5 rather than 5.0000. And so because the x is on the top here, and we want to get rid of this divide by 5 by doing the opposite, so we're going to multiply by 5 on both sides. So I'm going to multiply by 5 over here, and I'm going to multiply by 5 over here. So just a reminder that these two 5s will cancel each other out. And so now I'm just going to rewrite it so it looks a little bit neater. You don't necessarily have to do this step, but I will just for neatness sake. Let's move it down just a little bit. All right. So now we can determine what that side length is by taking 5 times sine of 34.5 degrees equals. So you punch into your calculator. 5 times your sine button, 34.5, close the bracket, hit equals. And you're going to get an answer of x will equal, x equals 2.8, and we're dealing with inches. So we know that on our triangle here, way over here, this side equals 2.8 inches. All right, we're going to flip to the next. So you're going to notice that this stuff at the top is pretty much all that we already solved. So you can just scribble that part out. We already solved it on the last page. So we're going to take a look at example 2. So it says here, Vanessa needs to build a wheelchair ramp for a cottage in Whiteshell. The ramp must meet the porch, 0.35 meters above the ground, and the distance along the ground from the start of the ramp to the base of the porch must be 4.25 meters. So what angle of elevation and ramp length should Vanessa use? So the first thing that they say is they tell us to sketch a right triangle to show a side view of the ramp. Label the lengths of the legs. Use X degree to represent the angle of elevation and R to represent the ramp length. So we're going to draw our triangle. And they only gave us this tiny little spot to do that in. So R represents the ramp length. X degree equals the angle of elevation. 0.35 meters represents the height. And 4.25 meters is the base of the ramp. So I hope you were able to make your triangle look a lot better than mine. Now it asks us, what is the ramp's angle of elevation to the nearest degree? So first of all, we have to identify our pieces of information here. So here's our angle of elevation. And we want to solve for this R. And we've got two pieces of information that we can use. So if we're looking for R, the R is the hypotenuse. I'm just going to use a different color here. So this is the hypotenuse because it's straight across from the right angle. What is this side in relation to X? So the side that's right beside it in relation to X, that's called the adjacent. And this side that is directly across from X, this is the opposite. So what we could do is we're going to try and find X first. We'll worry about R after. So here we've got opposite over adjacent. So using our trigonometric functions, we know that opposite over adjacent means that we're going to be using tangent. So we're going to use tan of our x degree equals the opposite over adjacent. So the opposite is 0.35. Adjacent is 4.25. And you can move this information right into the box here. And so we're going to use inverse tan, so tan negative 1, remember that means inverse, to solve this. So on your calculator, you're going to punch in second function tan, because that's what that negative 1 means. It's going to be, we're going to use the inverse or the second function. So second function tan, it opens up a bracket for you. You're going to type in 0.35, divide by 4.25, close the bracket, and then you're going to hit equals. So now you're going to get an answer of 4.7 degrees. But we want to round it to the nearest degree. So 4.7 degrees is about 5 degrees. So now we've solved what R is. We've solved what X is. So this is 5 degrees right there. So now, is your answer reasonable? By all means, it's reasonable. Yes. Because if it was larger, let's put it this way. If the degree was larger, the ramp would be steeper. And if you're making a ramp for a wheelchair, you do not want a steep ramp at all. Now we're going to use the Pythagorean theorem to calculate the ramp length, the r, to 2 decimal places. So we're just going to put our reminder just over here what our Pythagorean theorem is. So remember, we're taking a squared plus b squared equals c squared. And if we look back at our triangle over here, c squared always has to be the hypotenuse. So that's the part we're trying to solve, the r. And this could be a squared and this could be b squared. So we're going to fill in. So 0.35 squared plus 4.25 squared equals, and we're going to just call this r squared, not c squared, r squared. So we're going to figure out what 0.35 squared is. So you're going to punch that into your calculator. You're going to use your x2 button. So 0.35 x2, hit equals, and it's going to tell us that it is 0.1225 plus, and I want you to find out what 4.25 is. So 4.25, hit that x squared button, equals, and it tells us that it is 18.0625. We're still trying to figure out what it is. So it's still r squared. So we're going to solve for this. You're going to add those together. 0.1225 plus 18.0625, and we get 18.185. But that's not our final answer because we need to square it. This actually should have a little square number here. So we're going to square it by using our square root button. We have to square root it in order to find out what r is by itself. That's what I mean to say. So we're going to square root it on both sides of the equal sign. That's gone, that's gone. So 18.185 square rooted is going to give us the answer of 4.26. So that's what the length of the ramp should be in meters. Okay, so you have the practice to do, numbers 1, 2, 3, 4, 5, and 6. So I actually just want you to concentrate on, you're going to just do these ones. So do number 1, 2, 4, and 5. That's all I want you to do. 1, 2, 4, and 5. So you're going to work on that for me and finish those up. If you have any questions and you're not sure what you're doing and you need clarification, ask any of the adults in the room. And if you're at home doing this and you need just a quick answer, you can give me a text, you can send me a message through Teams, or you can email me at home. So I hope you do okay, and I think you will, and I will talk to you soon.